We'll take these three examples. First, negative 4 minus 4i. Now we know since the horizontal and vertical are the same, we're on one of these perfect diagonals. But it's not 45 degrees because horizontal and vertical are both negative. So we're down in quadrant 3 at 225 degrees, or 5 pi over 4 radians. Now how about the length of the radius, the distance from the origin to that point? Well, this expression, square root of x squared plus y squared, isn't usually too lengthy, so we can always go there. Square root of 32 and simplify 4 radical 2. So we've got this number in trig notation. 4 radical 2 times cosine plus I sine 5 pi over 4 in radians, and in degrees 225 degrees. The next one, radical 3 plus I. Well, we know this I is a 1i, and just like a good visual clue is when our real term and the complex coefficient, imaginary coefficient, are the same, it's going to match up with one of these perfect angles, 45 degrees, 135, 225, 315. The other points that we know on the unit circle were the radical 3 over 2 matched up with a 1/2. That represented all these other points and their reflections. So when I see radical 3 in one term and a 1 in the other term, I'm right away thinking about, well, if it's radical 3 over 2 and a 1 over 2, I know exactly where that is. That's right there at 30 degrees. I know that from unit circle. Horizontally radical 3 over 2, vertically a 1/2, that puts us right there at 30 degrees, or pi over 6. But what do I do to account for that I just threw this over 2 onto each term? Well, I just divided by 2, so I'll do the opposite and multiply by 2, and I'll put that outside of parentheses. And now I can see right away, there's my value of r, it is 2. I pulled it outside of parentheses, and I could see coordinates on the unit circle, radical 3 over 2 and 1/2. So a quick way for me to see the radius, and then let's plug in 30 degrees, and remember our x-coordinate is cosine 30 degrees and the y-coordinate sine 30 degrees, so we're writing 2 times cosine 30 degrees plus I sine 30 degrees, or this way abbreviated. If we choose radians, we're using pi over 6. Last example, positive 2, no imaginary part. Since it's on an axis, the r value is exactly what we see, equal to 2, and we know the angle measure horizontally in the positive direction is 0.